Good evening all. You are welcome to Tutorials with Formatante the Schoolboy. Today we are going to take a look at chemistry. Children, come and clean this board fast. In our last class, we stopped at distinguishing between pure and what? Impure substances, right? That's where we stopped in our last class. And we were able to define and explain with examples pure substances and what are impure substances. And we said that pure substances are what and what? A compound is a pure substance, and an element is also a pure what? Substance. Now, what of impure substance? The mixture. Example: a flood water is a mixture. We also mention alloys, right? Like bronze, right? And we gave examples of what? Mixtures. Now after that we now went straight to the differences between what? Mixture, between what? Pure and what? Impure substances. And from what we listed, what we are supposed to cover under the topic. This topic is all this I'm saying now are under the topic separation of mixtures and purification of chemical substances. After that, we went a step further to talk about a test for purity. Are we together? Test for what? Purity. How we employ the melting point and boiling point of substances to determine their what? Purity. And we say that for a solid substance that is pure, for a solid substance that is pure, that the melting point is the same thing with one we have in the what? Literature, because there is no other substance there. There's no contamination. But if a solid substance is contaminated, has other substances or constituents present in it, the melting point will do what? Decrease, yeah. And even though it generally decreases, it will not be a point, say. It will be a range. Because if you start melting at a particular temperature and finish melting at another temperature, that's why it's a range. So after that, we talked about liquid. What actually happens in liquid? When a liquid is pure, the boiling point is what? The same thing with what you have, at least the same thing with what you have in the what? Literature. Are you together? But when the liquid is contaminated, has impurities, the boiling point to do what? Increase. And the boiling point to do what? Increase. It will start boiling. But at the point where it will turn to whatever gaseous state it will turn to, it will be definitely higher than the boiling point of the pure sample. I used what you do almost every day in your house to explain that. I use if you are boiling ordinary water, and if you are cooking yam, you put yam in the water and cook it. I ask you, will the temperature at which the two of them boil be the same thing? You said no. Because of the presence of yam, the temperature at which that thing will boil will be very high than the what? 100 what? Degrees Celsius, which is normal boiling point of what? Water. You know about boiling point? Yeah? Good. Now, today we have look at boiling and melting point. There are nothing much to say here. We have already defined boiling point, right? In our listing, right? Right? In the last class, we already defined what the boiling point is. So we can define boiling point for us. Fast. No time to waste. Fast. Define boiling point for us, Kamsi, as we defined it in our last class. Oh yeah. Oh yeah. You don't know? We are not in the last class? No. You must know it. Or your answer. You are in this class, so don't tell me you don't know it. I won't take that. Oh yeah. What is boiling point? Oh yeah. Oh yeah now. Who defined boiling point for us? Huh? We explained this in our last class. See. At which? Not by which. The temperature at which what happens? Huh? What is vapor pressure in the first place? Huh? Huh? Now listen carefully. Now listen. Now listen. Before actually, if you have a liquid now, if you have a liquid, let's say what the water. If you pour water in your pot and cover the water, right? Now, and heat the water. As you are heating the water, the temperature is increasing as you supply heat to the pot, right? The heat will be transferred from the pot to the water, liquid inside the what? Pot. Now, the temperature is increasing. Now, it will get to a point, you know that if you study kinetic, Chine, I want to see your face. I like seeing the face of my student. Don't hide behind. Separate. Go to the extreme so I can see your face. I like seeing the face of my students, so I know if they are following me or not. Now, I'm explaining something now. Listen carefully. If you, from kinetic theory of matter, you know we have 3 states of matter. Remember, right? 3 states of what? Matter. We have the solid state, liquid state, and what? Gaseous state. In the solid state, the particles that make up the matter are together. They are compact. They are together. There is no movement. They can just be vibrating around a fixed point. The particles are together in a solid. Am I communicating? Now, they are together in a solid. In liquid, that means the intermolecular or interparticular force is very what? High in what? Solid. But in liquid also has what? Particles that make up the what? Liquid. The forces that held the liquid particles together are not as strong as that of what? Solid. That's why you can pour liquid easily. That's why you can do what? Pour liquid. They glide over each other. Am I completing? You can easily pour liquid, but you cannot pour solid like that because the forces are very, very what? Tight, close. Now, but in gases, in fact, the forces have been broken down. That's why gases fly anywhere they want to. That's why you can be here. Chine, come here and stay. Come here. That's why you can be here and be perceiving the of gas released somewhere. Do you know why? The particles are free. They can go to anywhere freely. But liquid are not that free. Liquid, even though liquid is not fixed like solid, but they are not completely what? Free. Now, if you have a solid that and keep applying heat in that solid, as you apply heat, these particles of that solid will be gaining energy, because you know heat is a form of energy. As heat is entering, they will be gaining energy. It will get to a point, if they get energy to the extent that their average kinetic energy has increased to the extent that it has overcome the intermolecular distance, they can break up. That's why you can heat a solid, it will melt. Does it make sense? They can break up depending on the temperature you want to you heat it to. So how the higher the temperature, the more heat, the higher temperature, the harder, the stronger the intermolecular force in a particular solid, the higher amount of heat energy you need to break this what? Bond. Am I communicating? That's why some solid you can just heat and they'll melt. Some you heat to 1,800 and something degrees Celsius before they will do what? Melt. Are we together? Now that is solid. Now if you heat that particle that has already broken, at least to some extent, from each other, will gain more kinetic energy than they will even become. They will break up entirely from the what? Entirely and become free. That's why they can turn to what? Gas. Am I communicating? Am I communicating? Now, that is what happens when you apply heat. Now let's come down to liquid now. You understand the general view of intermolecular, the kinetic theory of matter, and what have you. Now, when you now have pour something like water in a pot and heat that water, the already loosened particles will start gaining kinetic energy as you heat. The heat energy you are supplying from the heat source to the pot, the pot will be transferring, conducting the heat, and it will be entering the water. The water there, the particle will be gaining that energy as mechanical energy, specifically kinetic energy. And as the energy increases, the more they get this kinetic energy, the more the intermolecular forces is doing what? Breaking down. And the more it breaks down, it will get to a point they will leave the surface of the liquid. We call it what? Evaporation. When they now leave the surface as what? Gas. When they now leave the surface of this is the pot. This is the pot. This is the heat source. Bunsen burner or what have you, anyone you call it. This is the water. This is the water level. This is the cover of the pot. This is the surface of the water. The particle inside gain energy and start leaving this surface as vapor. As they are leaving this surface, they are hitting the wall of the pot and the cover of the pot. So will hit and lose energy and come back and enter the water again and gain more energy and come up again. This is what they keep doing. Chine, after writing this, you're writing. Is this what I'm writing? This is what you're writing. Are you sure? As they are doing that, above this surface, they exert pressure. What is pressure? Pressure is force per unit area. As you hit a surface, you apply what? Pressure. So these particles, as they are hitting these walls of this pot and the cover and going down, coming up, there's a pressure they apply at this point. This pressure is called what? Vapor. Vapor what? Vapor what? Pressure. This pressure is called what? Vapor pressure. Now, this is what it will keep doing. The pressure will be increasing. There has been already an atmospheric pressure around the place, around this pot, around whatever surrounding situation. Hope you know. Are you aware? There's an atmospheric pressure here. Are you aware? Are you aware? Now, as this vapor pressure is building up and you are hitting it, the heat is entering, the vapor pressure is increasing. It will get to a point where this vapor pressure here will be equal to the atmospheric pressure, prevailing atmospheric pressure surrounding the place. What will happen? Once they are equal, boiling will do what? Starts. Remember, as you are heating this thing, as you are heating, boiling occurs, put it down, boiling occurs when the atmospheric pressure is equal to what? When the vapor pressure of these particles here is equal to the what? At prevailing atmospheric what? Pressure. Boiling occurs when the vapor pressure of the water molecule is equal to the what? Atmospheric pressure, not what I say, liquid molecule, please. When the vapor pressure, just say vapor pressure because it has already left what? Sorry, hope you know. Simply say when the vapor pressure here is equal to the what? Prevailing atmospheric pressure. That's when boiling does what? Occurs. Now remember that as you are heating this, if you have a thermometer now, if you put a thermometer here now, As you are heating, look up. If you put a thermometer while you are doing the heating, as applying heat, temperature is rising. Hope you know. Are you aware? As you apply the heat, temperature is what? Will be rising. That particular temperature at which you will read from your thermometer, if the vapor pressure equals the atmospheric pressure at 80 degrees Celsius, that means the boiling point of that liquid is what? 80 degrees what? Celsius. But for water at 100 degrees Celsius, that's when the atmospheric pressure will be equal to the what? Vapor pressure. And that's when the water will start boiling. Am I communicating? So that is what meaning of what? Boiling points. So boiling is a phenomenon that occurs when the atmospheric pressure over a liquid is equal to the what? No, I mean the vapor pressure build up above a liquid is equal to the what? Atmospheric pressure. Boiling is a phenomenon that occurs when the vapor pressure built over a liquid is equal to the what? Prevailing atmospheric what? Pressure. Prevailing, that's surrounding pressure, the pressure of the surrounding atmosphere where the boiling is taking place, where the heating is taking place. Now, but boiling point is that temperature. Note the difference. So boiling point is that temperature at which the boiling does what? Occur, or define it proper. Boiling point is the temperature at which the vapor pressure built over a liquid is equal to the what? Prevailing atmospheric what? Pressure. Does it make sense? Good. That's what's called boiling points. So with this, you can be asked using with kinetic theory of matter to explain boiling or boiling point. I believe you can explain that. Even instead of drawing sketch, drawing it and explain it. For those that are writing WAEC, you can explain it. You can with this now explain now. You can explain this. Hope you, true of us, good. So if you now get your textbook and read it more, you will understand it better. Okay. So please, this is the difference between what I succeeded in talking about, explaining to us what we mean by atmospheric pressure. I've also succeeded in letting us know what we mean by what? Vapor pressure. Then also boiling and what? Boiling point. I even explain kinetic theory of matter. I even explain the relationship between increase in temperature and average kinetic energy of what? Particles, right? I've explained up to 6 things now. You say what? Just okay. Now, so that's why have you better to ask yourself, why is that if you pour water in a pot and heat it, the water that is in the pot, if you now open the pot and turn the cover, you see the water in the cover. How did it disappear from the pot and enter the? When did it climb there? When they climb there, this is what happens. It will leave the water surface as vapor. When it hits the cover, it will lose energy and turn back to liquid. That's what happened. And that's also what explains. I think I've explained this in this class. Why you get cold water and keep cold drink, chilled Coke in a hot afternoon. You keep it on the table to go and buy gala to come. On coming back, you notice that the Coke, we have a lot water droplets on the bottle. Where did the water come from? Is the vapor in the atmosphere. You're not seeing it, but they exist in the atmosphere. When they come in contact with that bottle, they will hit the bottle. They hit you now, but you won't know. They will hit your head, hit your hair, hit your clothes. You won't know. But why you notice it in bottle? That the bottle is cold. So when they hit that bottle, the bottle will bring down their temperature far below room temperature. They will turn to what? And they lose energy. They lose energy immediately and return to what? Liquid. That's why you see them on the bottle. So they didn't come from the bottle. It's the vapor pressure in the air that hit the bottle and lose energy. They will fly. Okay, Alpha, where are you going to? Let me look around here and see what's going on here. Okay, now go there. They come. As Chid is flying, Chid will now hit the bottle. Okay, will now say, hey, Chid, don't go. Because it will turn to what? Liquid. And they will bury Chid. Because Chid has turned to liquid. and they will keep flying. Okay, we'll start saying, don't even go near that black thing. No. If you go there, you don't remember, they will fly and disappear from the bottle. Because they don't want to turn to what? Liquid. That's what happens. Now let's look at another thing I want us to understand. Yes. Are we together? So I think I've explained that if a substance is pure, it has a specific what? Boiling point, right? But if it's impure, the boiling point will do what? It will increase, right? It will increase, yeah, because it's not pure. Okay? Whether that range within your no range, it will still do what? Be above the what? Normal temperature at which it should have what? Boiled. Now let's go. Now, from this I explain now. Let me know someone that thinks. From this I explain now. What do you think is the melting point? Remember, we are treating. Our topic for today is melting point. Remember, our outline is what? Boiling point and what? Boiling and what? Melting point. Go to the outline I gave you last time. According to the Johnstown, it's melting boiling point and what? After pure and liquid substance is what? Boiling at what? Melting point. Now, from this thing we are speaking now, who can confidently talk to us on melting point? What do you think now is the melting point? Oh yeah. Who? If you know it come out with boldness, I don't want side talk. If you know it come out with boldness. Can you see how I speak with authority? Don't I? I want you to speak to us in that manner. Come and speak to us if you are sure what you're saying. Don't stay by the side and be doing show. Come out and speak to us with authority. What melting? Start from kinetic theory of matter, then hit it. Define melting, then define melting point. That's what I want to hear from you. Start from kinetic theory of matter, come up, explain melting using kinetic theory of matter, then tell us what melting point is. Oh yeah, and how it concerns purity of matter, purity of solid. Who? Come out now. Who? Children, come out. Come fast. Let's hear from you. I was watching you. You are one man telling you go. I want to say don't go. You did like this. Now I've seen you. Come out. I want to hear your voice from here. You know me, you're talking to you're talking to all of us. Explain melting using kinetic theory first before you can tell us what melting point is. Is it what? It's solid.
Yes.
Solid, vapor pressure, solid. In Oguya?
No.
It's okay. It's okay. Let me explain. You can go and sit down. Let me explain. Now, you know a solid, listen carefully. Solid particles are like this. They are bound like this. Are you aware? Are you aware? They are bound together like this. The force of attraction that binds them is so strong. Okay? Okay? This is what? Solid. This is how the particles are. Unlike liquid, where particles are together like this. They are not too compact. They are just like this. The intermolecular forces are not that strong in what? Liquid. But in gas, they have been broken down. This one is scattered anyway. Cut this side out. This one is this side out. This one is this side out. Exerting pressure anyhow. In what? Gas. This is kinetic theory. Explain the three states of matter. But when you say melting, you're talking about what? Solid, okay? Now look at this thing. This solid now. Look at how the particles that form the what? Please, Mike, are you with us? Are you sure? Can you say with us? Are you sure? Now, this is what solid. Now, if you apply heat, I'm using kinetic theory of matter to explain what? Melting. If you apply heat, if you apply what? Heat energy from this heat will be transferred to this as what? Kinetic what? Energy. They will gain energy. Remember, law of conservation of energy. Energy is not what? Lost, but can be transformed from one form to what? Another. Here, energy is being transformed from heat energy to what? Mechanical energy. The particles here will gain this heat, and as they gain the energy, they will be vibrating. They will be vibrating within themselves. Oga, leave me alone now. Leave me alone. I'm waiting. They are getting more energy. They are dragging. They hold each other. The force is binding. Oga, leave me now. Waiting me here. We'll be here for like how many years now? Leave me alone now. They will be vibrating, dragging with each other. We call it what? Vibration. That vibration is that they are dragging with each other. Leave me. I won't leave you. You go. I won't leave you. This is what they will do, They're getting more energy. I will go. As they are doing this thing, next thing, the force between them will do what? Break. And they will become like this. You can say, meh. They will just be. Now, that's heat you apply, they gained this energy they gained and got that this attraction, this binding force is now broken down. As this applying this heat, temperature is increasing. This thing happened at a particular what? Temperature. That breaking of this binding force between the what? Particles of this solid happened at a particular what? Temperature. That temperature at which this thing happened, they break down and become loose. And of course, when this happened, they will turn to what? Liquid. Hope you know. That temperature at which this happened is what is called what? Melting point. Melting point. That is the temperature at which they break down like this and become what? Liquid. So melting point of a solid is the temperature at which the particles of a solid, having gained so much kinetic energy, so much kinetic energy, overcomes the force binding them. Overcome the force binding them, leading to the collapse of the crystalline structure. Melting point of a solid is the temperature at which the particles of a solid, having gained so much energy, overcome the forces binding them, leading to the collapse of the crystalline structure. Melting point of a solid is the temperature at which the particles of a solid, having gained so much kinetic energy, overcome the forces binding them together, leading to what? The collapse of the what? Crystalline structure. That is melting point. Okay. I'm coming now. I'm coming. Now, while melting is the collapse of the crystalline what? Structure of what? Solid. Due to the overcome overcoming of the forces binding the particles of a solid together. I say that melting is what? What does it last? Melting is what? Is what? Of what? Okay, put is the collapse of the crystalline structure of a what? Solid. Put it there, please. The collapse is the collapse of the crystalline what? Structure of a what? Solid. Due to what? Of binding the particles of what? Solid. Binding the particles when they gain what? So much what? Kinetic what? Energy. It is the collapse of the what? Crystalline structure of what? Solid. Due to what? The overcoming of the what? Of the what? Forces binding the particles together when they gain what? When they gain what? So much what? Kinetic what? Energy. Because it's that energy that they gain that help them to do what? Overcome the what? Forces binding what? Them together. Therefore, they will be what? collapse, because that thing that hold them together will do what? Scatter. Three of us, and they will free, enjoy it. That's not will. But they are tired of staying what? Together. So that what actually happens in what? Solid. Now, of course, I've already explained this before, that the melting point is used for purity, testing purity, just like boiling point. And if it's a pure substance, the melting point, it will be a point, true of us. But if it is an impure substance, it will start melting at a particular temperature and end at a particular temperature. It's a range, and is lower than the melting point of the pure substance, because of the impurity present. Is it clear? Now, in as much as you are heating this, there are some solid that you heat. Okay, go and get iron, go and get your key and put in your pot and heat. Your gas will finish. You go and buy more gas, it will keep finishing. You buy your gas, it will finish it. It will finish it. You grow old. Because by the time you go and buy another gas and fill, the one you heat will cool down. In fact, the water self can't even stay to heat it. The water will evaporate. You may heat. Even the gas, depending on the nature of what they use in making the cylinder, it will even melt. To tell you that you need a very strong heating material. Some you heat them in a furnace. There's one video I was watching in one Indian company, how they were doing this sewing machine, how they mold it. They will heat metal, heat it until it turns to what? Liquid, red, hot metal will turn to liquid. Do you know the temperature at which they will heat that thing to melt it to become liquid, red? If I pour that into Michael will just melt. Michael will disappear, boom. You will see bone. They will make it be red. They will carry it as liquid, red, and be going. They will go and pour it before it will come. You know, sewing machine you use now, how they do it. Now, this is high temperature before it will melt. But there are some very weak. They are intermolecular forces, even though they are solid, but they are not even that strong. Once you heat them small, bam, they won't even want to go to liquid. They go to the gas straight. Just small heat, bam. They won't even go to liquid at all. You see, the person will say, okay, boom, gas, boom. They won't even touch liquid. It depends on the nature. This one is not strong. Is strong. This one is just weak. What is between them is weak. Are weak intermolecular forces. They are not that strong to hold them together. Any small, some cells, you don't need to heat them. Just keep them here and go. They will start disappearing. And for me, was gas. So this process of moving from solid to gas is called what? Sublimation. We'll treat this when we talk about kinetic theory of matter. We have not discussed that. We still do it as a topic. But I just used it to explain, but if I don't mention it, you won't understand boiling and what? Melting. That's why I mentioned kinetic theory of matter. We'll still treat kinetic theory of matter as a topic for you to understand it better. But I believe with this explanation, it will be easy for you when we go there. So this is what boiling and melting is all about. So we have treated pure substance and impure substances under the topic separation of mixtures and purification of chemical substances. We've treated pure and impure substances. We've treated melting and boiling and melting points. Then we have, even before now, we've treated elements compound and what? Mixtures. Now, we also treated the fourth topic here, chemical and physical changes. We've treated them, right? Now, the next topic we will enter in our next chemistry class is separation techniques. Now, if we are under separation techniques, we'll talk about different, why we even do what, how you do them, the separation of mixtures, and different techniques you use to separate what component, constituent of what mixture. That will be our next topic, separation process / techniques. If you go through it before you come to class, you appreciate it. So I want you to go through your textbooks, go through whether you are it is entering or whether it's not entering. Just read it. If you read it, separation process and techniques. You are not there when I give the outline. Maybe after you copy it from China, yeah? That's the outline we are following. So, I don't know if there's any question. Any question? All right. In the absence of any question, we'll stop here for today. But before you go, I will write down the assignments on chemistry on the board. All right. Thank you very much for your attention. See you. Today is what? Friday. Okay, see you. Okay, WAEC people will see you tomorrow on Saturday, and the other center. Others see you on Monday. All right. God bless you.